Hello, dear learners. This is the third lecture on Chapter 7 for grade 12 physics. So I uploaded first and the second lectures to my video. ይሄ የ12ኛ ክፍል የፊዚክስ ትምህርት የሰባተኛ ቻፕተር ሶስተኛ ሌክቸር ነው። ስለዚህ ሁለቱን የመጀመሪያዎቹን ሌክቸሮቹን ዩቲዩብ ላይ ስላለ ከዛ ሄዳችሁ እዩት። ያልገባችሁ ጥያቄ ካለ ያልተመለሰላችሁ ወይም ደግሞ ግልጽ ያልሆነላችሁ ጥያቄ ካለ ጥያቄዎቹን እዛው ላይ አስቀምጡልኝ። በማንኛውም ሰዓት ባስቀመጣችሁት መሰረት ጥያቄዎቹን ለመመለስ ሞክራለሁ እና ይሄ በነፃ በራሴ ተነሳሽነት ያገዝኳችሁ ያለው ነው። አንደኛም በዚህ ውስጥ የኔ ልጅም በዚህ አመት ተፈታኝ ስለሆነች ለሷ ብዬ ባዘጋጀሁት ሌሎቻችሁ እንድትጠቀሙ ማድረገው ነው። ስለዚህ ወደ ሶስተኛው ሌክቸር ነው የምንሄደው ዛሬ። the third lecture called it is about root mean square or r.m.s values in alternating current circuit. Before going to this third lecture, I want to revise this second lecture. Okay, let me go back to the second lecture. It will take some 10 minutes revision. So then after we'll go for today's lecture or recent this root mean square values in AC circuit lecture. So be patient and please follow the lecture. ወደ ሶስተኛው ከመግባቴ በፊት ሁለተኛው ላይ አንዳንድ ነገሮችን እንትን ለማለት ሪቫይዝ ማድረግ ፈልጋለሁ። ስለዚህ ወደኋላ አንድ ጊዜ ሊመለስና አንድ 10 ደቂቃ የሚፈጅ ሪቪዥን እናያለን። ለምን ሌክቸሮቹን ለማያዝ እንዲጠቅመን ወይም ደግሞ ለእናንተም ግልጽ እንዲሆንላችሁ። ሁለተኛው ሌክቸራችን ምንድነው? ኦልተርኔቲንግ ከረንት ጀነሬተር አንድ ትራንስፎርመርስ ነው። ስለሱ በአፕሎድ አድርጌያለሁ በዩቲዩብ ላይ፣ ከዛው ታገኛላችሁ። ዩቲዩብ ቻናሌ ይሄኛው ነው። ወይም ደግሞ በሌላ አጠራር ቀጥታ ታይፕ አድርጋችሁ ለመግባት ከፈለጋችሁ ዩቲዩብ ላይ where is okay, so advanced engineering educational channel የሚል አለ። advanced engineering educational channel ብላችሁ ቀጥታ መጻፍ ትችላላችሁ። ስለዚህ ከዛው ታገኛላችሁ። ሶ ወደዚህ ስንመጣ እዚህ ጋር ምንድነው የተማርነው? በሰከንድ ሌክቸር ላይ የተማርነው ምንድነው ለምለው what is direct current, what is alternating current የሚሉ ሁለት ኢምፖርታንት የሆኑ ነገሮችን ለመለየት ሞክረናል። ዳይሬክት ከረንት ከምንድነው የምናገኘው? ኦልተርኔቲንግ ከረንት ደግሞ እንዴት ይፈጠራል? ወይም ደግሞ induced electromotive force ከኦልተርኔቲንግ ከረንት እንዴት ይፈጠራል የሚለው ነገሮች አይተናል። ሲምፕል ኤሲ ጀነሬሽን ኮንስትራክሽን ለማየት ሞክረናል። ከዛስ ትራንስፎርመር ማለት ምንድነው? ትራንስፎርመር አላማው ምንድነው የሚለውን ነገር ለማየት ሞክረናል። and then transformer equation, what is transformer equation? እነዚህ ነገሮች አይተናል። ስለዚህ በቀላሉ ሳምራይዝ ማድረግ የዳይሬክት ከረንት ሰርኪዩት ይሄን ይመስላል። ኦልተርኔቲንግ ከረንት ሰርኪዩት ሳይኑሶይዳሊ ሪቨርሲብል ወይም ደግሞ ኦልተርኔትሊ ቼንጂንግ ዳይሬክሽንስ ለሚያደርግ ይሄን ይመስላል የኦልተርኔቲንግ ከረንት ሰርኪዩት። ኦኬ ሶ የሳይኑሶይዳል ከረንት ነው፣ ቮልቴጅ ነው። ስለዚህ ኦልተርኔቲንግ ከረንት ላይ we can see sine wave. This is a sine wave. Okay, this is alternating current or alternating voltage representation. Then simple AC generator construction. We have coil here. We have one and two rings here. We have magnetic field. So our coil is in magnetic field. So when this happen, there is torque will form and produce rotational motion then that rotational motion produces electric current. So it is connected with external circuit for further application. And then the magnetic flux given NBA cos theta, and the rate of flux change is known as the magnetic flux change, which is given as this formula. And more delta with a differentiate ወይም ደግሞ ደሪቬት አድርገን የምናገኘው ፎርሙላ እዚህ አለ። So induced electromotive force is equal to NAB omega sin omega t. ይሄን ለማግኘት ሞክረናል። ኤግዛምፕል ሰርተናል በዚህ ውስጥ። So and then transformer ጋር መጣ። So transformer is directly to change some voltage level up or down. Okay, that is the function of transformer. And transformer primary coil እንዳለው. So primary coil is with alternating voltage or current, and secondary coil is it is not alternating, but it induces electromotive force from the primary coil. Okay, this induced electromotive force or the voltage in secondary coil is obtained from primary coil. So which induced electromotive force is equal to minus n secondary. This is n secondary delta pi over delta t. So this is transformer. Okay, so transformer consists of the core, it consists of the solenoid, it consists of circuit, okay, primary circuit and secondary circuit. Okay, so this is the constructional feature of transformer. And this is the way how transformer works. Look here, the magnetic flux or magnetic field is moving around the two coils. Okay, so here there are primary coils, secondary coils, primary voltage, secondary voltage, the core, the magnetic flux, which is moving. Okay, BP over Vs is equal to NP over Ns. BP over Vs is equal to NP over Ns, known as the transformer equation, which is on Is over Ip. So this is what we have learned in the last class. So what is step-up transformer and what is step-down transformer? That is one thing. So we can balance the amount of voltage which we require using the transformer. So it can reduce the high voltage to low, or it can increase the lower voltage to the higher. So that is the transformer function. That is for the safety aspect as well as economic aspect. Okay, the economy and the safety ሲባል voltageን ከፍና ዝቅ ማድረግ እንችላለን በምንፈልገው መጠን ለተጠቃሚው ለማድረስ ኦር ከሜን ፓወር ስቴሽን ወደ ሰፈራችን ድረስ የሚመጣውን ፓወር ዩቲሊቲ ሎስ እንዳይኖር ዳይሬክት ቮልቴጅ ይመጣና በትራንስፎርመር እንደገና ደግሞ ከፍና ዝቅ ተደርጎ ሊደርሰን ይችላል። ስለዚህ ያ ማለታችን ነው። እና እዚህ ጋር የስቴፕ አፕ እና ስቴፕ ዳውን ትራንስፎርመር ለማየት ሞክረናል። ዴፊኒሽኑ ምንድነው? ቮልቴጁ እንዴት ነው? ዋይንዲንግስ ፕራይመሪ ላይ ሰከንዳሪ ላይ፣ ከረንትስ ፕራይመሪ ላይ እና ሰከንዳሪ ላይ፣ ሬቲንግ ኦፍ ዘ አውትፑት ቮልቴጅ ሬቲንጉ ምንድነው? በስቴፕ አፕ ላይ ለምሳሌ በኪሎ ቮልት ደረጃ ወይም 11 ኪሎ ቮልት ቢሆን እዚህ ጋር በቮልት 110 24 20 ቮልት 10 ቮልት ምናምን እንደዚህ ያለ ትንሽ ቮልት። ስለዚህ ሰከንዳሪ ላይ እንደዚህ ሳይዝ ኦፍ ዘ ኮንዳክተር የሚያስፈልገው ኮንዳክተር ዋየራችን ሳይዝ በፕራይመሪ ሰከንዳሪ። አፕሊኬሽኑ ለምሳሌ ስቴፕ አፕ ትራንስፎርመር የሚያስፈልገን ፓወር ፕላንት፣ ኤክስሬስ ማሽን ላይ፣ ማይክሮዌቭ ላይ ስቴፕ አፕ ትራንስፎርመር ያስፈልገናል። ለምን? ኢንክሪዝ ለማድረግ ቮልቴጅ ሌቨላችን ኢንክሪዝ ለማድረግ የምንጠቀምበት ነው ስቴፕ አፕ። ስቴፕ ዳውን ደግሞ ቮልቴጅ ሌቨላችን ዲክሪዝ ለማድረግ ስለሆነ አፕሊኬሽኑ እዚህ ድሮፕ ቤል፣ ቮልቴጅ ኮንቨርተርስ ለነዚህ ነው የምንጠቀመው። ይሄን ለማየት ሞክረናል። በዚሁ መሰረት 11 ኪሎ ቮልት ከፓወር ስቴሽን ወይም ከተርባይን ከኤሌክትሪክ ሳፕላይ ኔትወርክ የመጣውን ወደ 415 ቮልት ለመቀየር 11000 ቮልትን ወደ 415 ቮልት ለመቀየር that means step down ነው። አሁን ይሄ ስቴፕ አፕ ሳይሆን ስቴፕ ዳውን እያደረግን ነው እና በፕራይመሪ ኮይል ተሰጥቶናል። ያልተሰጠን ደግሞ ሰከንዳሪ ኮይል። ስለዚህ ሰከንዳሪ ኮይል ካልኩሌት አድርገን 302 አግኝተናል ማለት ነው። ይሄን ፎርሙላ ተጠቅመን ከዛ ፓወር ትራንስሚሽን ለምንድን ነው ፓወር ወይም ኤነርጂ ኤሌክትሪካል ኤነርጂ ትራንስሚት የምናደርገው? እንዴት ነው ትራንስሚት በምናደርግበት ጊዜ ረጅም ዲስታንስ ከፓወር ስቴሽን to the users there is a great loss because of resistance of the wire, because of the length of the wire. ምክንያቱም ኮንዳክቲቪቲ እነዚህ ሬሲስቲቪቲ የሚባሉ ነገሮች አሉ እና እነዚህ የዋየር ራሱ የቻለ ሬዚስታንስ ስላለው ፓወር ሎስ ያጋጥማል። ፓወር ስንል current times voltage, the formula for power current times the voltage. ቮልቴጅ ማለት ደግሞ current times resistance ስለሆነ current square resistance ፓወር ነው እና በእንደዛ አይነት መልክ ሎዞች አሉ። የኛ ኤማችን ምንድነው? ፓወር ሎስን ሚኒማይዝ ማድረግ ነው፣ ትንሽ ማድረግ ነው፣ ትንሽ ሎስ እንዲኖር ማድረግ ነው። ብዙ ሎስ ባደረግን ቁጥር ፓወር አግባብ ያለው ፓወር ትራንስሚት ወይም ትራንስፖርት ማድረግ አንችልም እና እነዚህ ትራንስፖርቴሽን ምንሱ በኬብሎች ነው፣ በኤሌክትሪክ ኬብሎች ሃይ ቮልቴጅ ላይን ኬብሎች አሉና በእነሱ ነው እና ፓወር ሎስ ሚኒማይዝ ማድረግ ነው አላማው። ስለዚህ ትራንስፎርመር ምን አይነት ዲቫይስ ነው? ፓወርን ኢንክሪዝ ኦር ዲክሪዝ ለማድረግ ነው። በእያንዳንዱ ተርማል ከፓወር ሶርስ መጥቶ ወደ ከተሞች፣ ወደ ኢንዱስትሪዎች፣ ወደ ሰፈራችን በሚደርስበት ጊዜ በሚፈለገው መጠን እንዲደርስ እንደገና ኢንክሪዝ እና ዲክሪዝ ማድረግ መቻል አለብን እና that is called transmitting electricity። ስለዚህ ያ በዳይሬክት ከረንት ወይም ደግሞ ትራንስሚት ማድረግ ነው መጀመሪያ፣ ግን ያ በጣም ከባድ ነው። ሶ ለዛ ተብሎ በሳይኑሶይዳል ዌቭፎርም ማስተላለፍ መቻል አለብን እና እነዚህ ነገሮች ያየናቸው ወደ መጨረሻ ስንመጣ እነዚህን ፖይንቶች ለማየት ሞክረናል። so this is all about first second lecture. Now let me go to the third lecture of today's lecture. So the third lecture is about root mean square values in the AC circuit. Root mean square, r.m.s. Sometimes you can use it in capital letter, simply r.m.s without dots. In different books you can see different representation. Anyways, root mean square values of in AC circuit. What is that? Let's see. Look, alternating current has sinusoidal waveform. Now it is a sine waveform. This is a sine waveform. Start from 0, goes to maximum peak amplitude. I.m. signal peak amplitude. V.m. voltage peak amplitude of voltage now. So it goes to peak amplitude IP or I.m. P በሚለውኛ so peak ለማለት ይመጣል። That means pi over 2. Pi over 2 means 90 degree. It goes to 90 degree and then comes to 0. 0 is the mean position. Okay, and then goes to the throw. That means or the values. ዝቅተኛ ወደ ኔጌቲቭ amplitude, maximum negative amplitude, maximum positive amplitude ይደርሳል, then goes to 0. So it is alternatively ups and downs. It's with a sine form of representation, so that sine omega t. So considering this as omega t, the time period it takes to cover 2 pi. 2 pi is the time period. Okay, so this means that its magnitude is varying continuously, but average magnitude is 0. our average is 0, because average means this plus IP positive plus IP negative over 2 ስናደርገው 0 ይሰጠናል አይደለም? ምክንያቱም because equal magnitude but opposite direction, so the sum of the 2 over 2 is 0, so with magnitude average magnitude 0. okay, እዚህ ጋር ስንመጣ ተመሳሳይ representation ነው። it goes to high value, high max, positive max, again here negative max. Okay, and then I is equal to I max sine omega t. I max is the maximum amplitude, the amplitude of the sine wave. Okay, so for the current, then within 2 pi it completes one complete motion. So let's say and period ማለት one complete motion. The r.m.s stands for root mean square of AC, or instantaneous current value. AC ማለት ምንድነው? instantaneous current ማለት ነው። The r.m.s values of alternating currents is given by direct current which flows through a resistor, and the r.m.s value AC is greater than the average value, and the r.m.s value of sine current wave can be determined by over covered in half cycle. Okay, so now let's see here. So if we take this r.m.s ማለት እዚህ ጋር f of t as a time function ብዬ ቢወስድ current root mean square is equal to radical of 1 over t times integral of f of t square dt. ይሄ ፎርሙላው ነው። አሁን f of t ያችን ይሄ ነው። ይሄን በማስገባት እዚህ ጋር 1 over t, the time period to cover this is 2 pi ነው። እዚህ ጋር t is equals to 2 pi ነው። I am sin omega t as a whole square በምናደርግበት ጊዜ dwt ከዚህ የምናገኘው መጨረሻ ላይ IP over radical 2. IP over radical 2 is the r.m.s value. Okay, ይሄ እኛ የምንፈልገው r.m.s ቫልያችን ይሄ ነው። So IP is the peak current, so that r.m.s r.m.s is equal to IP over radical 2, which is equal to 0. So this is our result, which is 0.707 G. But average current for half circle, half በምንወስድበት ጊዜ look, for the half cycle, not full cycle. Full cycle, the average will give us 0. But for the half cycle, the average current becomes 0.637 I max. Okay, for half cycle, I average is equals to 0.637 times I peak. Okay, so that is for the half cycle average. So now let's summarize our what we have discussed. The peak current is the maximum value of the current IP. The root mean square r.m.s values of current value represents an equivalent effective steady value, which is given with this formula. This is I.r.m.s, which is IP over radical 2, 0.70 IP ማለት ነው። The half cycle average of the half cycle average. This is half cycle average of the current is given with 0.637 times IP. Again, peak voltage is the highest voltage. So r.m.s value of the voltage is similarly the same, this, okay, with peak voltage, and the half cycle average. Don't forget, it is not full cycle, but half cycle average is 0.637 times B peak. Okay, so this is for the voltage and current. So let's take one example on this. An alternating supply has a peak value of current, IP, is equal to 2.5 ampere for the current, and peak value of voltage, BP, is equal to 6 volt for the voltage. Find the average. Look, find the average. This average is half cycle average. Don't forget, half cycle average. Half cycle average. And the r.m.s value for the current and the voltage for this supply. So we have given IP 2.5 ampere, BP 6 volt. That means in the sign በእንትን ድሮ ብናደርገው ለምሳሌ ይሄ ሳይን ቢሆን with maximum amplitude 2.5 amps ቢሆን ይሄ ደግሞ ማን ነው ማለት ነው? ቮልት ነው የሚሆነው። ማን ነው? ቮልቴጅ ነው። So this is V, which is equals to BP sin omega t ማለት ነው። ይሄኛው ደግሞ ከረንት ነው። I is equals to ይሄኛው I is equals to IP sin omega t. Sin omega t. ስለዚህ ማክሲመም አምፕሊቲዩድ የአይፒ 2.5 ነው። ከዚህ ተነስቶ እስከዚህ ድረስ ማክሲመም አምፕሊቲዩድ ኦፍ ቢፒ ደግሞ 6 ነው፣ ከዚህ እስከዚህ። ስለዚህ እንደዚህ ማሳየት ይቻላል። Then we require to find I average, r.m.s, I r.m.s, B average, B r.m.s. ስለዚህ we have developed the formula for all of them. I average for half cycle, which is equal to 0.637 times IP. From that, we can get 1.5925 ampere. I r.m.s, which is equal to IP over radical 2, which is 0.707 IP, which gives us 1.7625 ampere. Okay. Similarly, V average for half cycle, which is equals to 0.637 BP, which is 3.822 volt. Okay, and V r.m.s, which is BP over radical 2. ይሄ ማለት ነው radical 2 አንድ ነገር አሁን BP over radical 2 ስንል ማትማቲክስ ላይ እንደዚህ ማድረግ አንችልም። BP over radical 2 times radical 2 over radical 2 ማድረግ አንችልም? እንችላለን። ይሄ ማለት ደግሞ ምን ማለት ነው? radical 2 BP over radical 2 times radical 2 ነው. So it is 2 root 2 BP ማለት ነው። B r.m.s is equals to just it is mathematical expression. ስለዚህ እንደው ኢንትረስትድ ከሆናችሁ በዛው ማትሱን ለማስታወስ እንደዚህ ማድረግ ማለት ነው። So this is all about this topic. Now what is the next? Resistive circuit and alternating current. Now let's go to the resistive circuit. What is a resistive circuit? So if we use the r.m.s value for the current and voltage through the resistor, okay, the r.m.s value for the current and the voltage through the resistors. Then for ordinary currents, the behavior of the resistor in an AC circuit is the same as the behavior of the resistor in DC current. Okay? So it is possible for two such waveforms to be in phase with each other. Means the peaks and throws at the same instance. Now, voltage and the current are in phase. ሁለት ነገሮች in phase ሆኑ ማለት ነው current ወደ positive peak ላይ ሲሄድ voltage also in the positive peak. Look, you can see this diagram. This diagram shows the relation between current and the voltage. They are in phase. ብዙ ጊዜ current እና voltage ተመሳሳይ አቅጣጫ ላይ sinusoidal wave በሚፈጥሩበት ጊዜ ያን in phase ነው የምንላቸው. So this is the current graph and this is the voltage graph. Okay. So ይሄን ምንድነው BP sin BP sin omega t ነው። ይሄኛው ደግሞ IP sin omega t. So they are in phase. ይሄ ማክሲመም ሲሆን ይሄ ማክሲመም ነው። አንዳንድ ጊዜ ለምሳሌ current positive maximum ሲሆን voltage negative maximum ሊሆን ይችላል. That is out of phase የምንለው 90 degree phase difference. Current lags voltage, voltage leads current የሚሉ ኮንሰፕቶች አሉና we have to consider those concepts here. So in this case, it is possible for two waveforms to be in phase. Look, they are in to be in phase. Okay, here they are in phase. That means they are in line, in the same order, in the same position at every moment. So the peaks and the throws at different times. So when we consider AC circuit, we need to know whether the current and voltage are in phase, in phase with each other or out of phase. Out of phase means when one is going the positive peak and if another goes to the negative peak, that is means out of phase. አሁን ለምሳሌ ይሄ ግራፍ ላይ ይሄ የከረንት ሰርኪዩት የከረንት ቢሆን ቮልቴጅ ደግሞ somewhere ይሄን ግራፍ እንደዚህ ባረገው extend ባረገው if the voltage starts from here and come like this, for example, this is pi over 2. If this is pi and if this is minus pi over 2. So consider this is current, this is voltage. So current leads voltage by pi over 2. Here zero position. So this is what we call out of phase and in phase. So in the resistor, in the resistor, the voltage and the current increase and decrease directly with each other. That means they are in phase, as you would expect it from the Ohm's law. Ohm's law, voltage is equal to current times resistance. That means this is called Ohm's law. So look, there is BP sinusoidal voltage is crossing here. This is our volt, and IP, which is moving in this, this is a resistor. You can use a resistor like this. Resistor እንደዚህ represent ማድረግ ይቻላል ወይም ደግሞ somebody እንደዚህ ማሳየት ይቻላል. So it is the same. This is symbol for R. Let me write it R here. So from this relation, current is equals to voltage over resistance. Now voltage BP sin omega t ነው። ስለዚህ voltage ቦታ BP sin omega t ስናስገባ BP R sin omega t is the current now. Okay, so this is the current. Now for pure resistive AC circuit, what we are talking here is pure resistive AC circuit. Okay, that means both current and voltage are in phase. That contains just pure resistance R. In a completely resistive circuit, there is no inductance. እዚህ ጋር አሁን ለምሳሌ ብዙ ኤሌክትሪክ ሰርኪት ላይ ኢንዳክታንስ፣ ካፓሲታንስ፣ ሬዚስታንስ ምናምን አንድ ላይ ሰርኪት ውስጥ ይኖራሉ። ግን አሁን ፒውር ሬዚስቲቭ ሰርኪት ስናወራ እነዚህ የሉም። ለምሳሌ ስለ ፒውር ኢንዳክቲቭ ሰርኪት ስናወራ we don't consider the capacitance and the resistance. When we are talking about pure capacitance circuit, we are not considering the inductance and the resistance. So now we are talking here completely resistive circuit. There is no inductance and there is no capacitance. What are inductance, what are capacitance? We will learn them soon now. ስለዚህ እዚህ ጋር ስንመጣ በእንደዛ አይነት look, ስለዚህ in both directions of the circuit, the AC, the alternating current and the voltage go forward and backward. As a result, the AC and the voltage take on the shape of sine wave or sinusoidal form. The power is wasted by the resistor. Obviously, a resistor opposes the flow of current, so that reduces the power in a completely resistive circuit. And the phase of the voltage and the current stays the same. That means both voltage and the current reach their maximum value, positive or negative maximum value at the same moment. Look, we can see here. This is current at maximum point, voltage at maximum point. So that is the time t. At the same time they reach to maximum point. So that the power is equal to current times resistance. No, current times voltage is power. Yeah, power is equal to current times voltage. So both of them are in maximum position. So our power diagram, this is the power. Okay, this is power. So our power is also here in the maximum point. Okay. That power is equal to V.r.m.s times I.r.m.s minus V.r.m.s I.r.m.s cos to omega t. But our cos is 0 this time. Means, sorry, this is sine, I think, because this part should be, yeah, sine. So this part, they are in phase. So it is 0 degree. So this part will be eliminated from here, and we have left this part only. This r.m.s means BP over radical 2, IP radical 2. So power current times voltage ስለሆነ ይሄን በመጠቀም ፋይናሊ የምናገኘው power is equals to this. ይሄ ማለት ምንድነው? ይሄ radical 2 times radical 2 ነው አይደል እንዴ? ስለዚህ BP IP over 2 ማለት ነው። So 1 over 2 times BP IP gives us the power. Okay. Now the resistor is passive device that does not generate or use electricity, but it is a device that turns the electrical energy into heat. So how a resistor wastes power? By converting electrical energy into heat energy. Okay, electrical energy aለ PE. When it is converted to heat, it will dissipate. ይህም የሚያደርገው ማነው? ሬዚስታንስ ማለት ነው ወይም ሬዚስተር ነው። ሶ ሬዚስተር ቼንጅስ ኤሌክትሪካል ኤነርጂ ቱ ሂት። ሂት ደግሞ ዲሲፔት ይሆናል። ዲሲፔት ሆነ ማለት ዌስት እየሆነ ነው ማለት ነው። ኢን ዘ ፎርም ኦፍ ሂት በሙቀት መልክ ዌስት ይሆናል ኤነርጂ በሬዚስተር በኩል ማለት ነው። ሶ ዳት ኢዝ some concept. Another is the capacitive circuit and alternating current. ቶፒካችን በአብዛኛው ስለ ኦልተርኔቲንግ ከረንት ስለሆነ ነው ኦልተርኔቲንግ ከረንት በየቦታው የምናነሳው እና what is capacitive circuit መጀመሪያ resistive circuit አይተናል። ኦኬ አሁን capacitive circuit ነው። in a resistive circuit voltage and current are in phase ናቸው. So there is no phase difference and the power is voltage times current over 2 is the average power. Okay, now in the capacitive circuit እዚህ ጋር capacitor ነው እያወራን ያለ ነው። when we talk about capacitive circuit we are talking about the capacitor. Okay, so when we talk about capacitor there are charges. capacitor ላይ ደግሞ capacitor plate ላይ ፖዚቲቭ እና ኔጌቲቭ ቻርጆች መኖራቸውን እናስታውሳለን። ስለዚህ ኤሌክትሪክ ፍሎ በሚያደርግበት ጊዜ ካፓሲተር ውስጥ የሚፈጠሩ ነገሮች we have a capacitor and an AC voltage በዚህ ጊዜ ካፓሲተር አለ እዚህ ጋር because this is pure capacitive circuit and AC voltage alternating voltage አለ ካፓሲተር አለ. Current is flowing through the circuit like this. This is the current flow direction. Okay, so the voltage, because that is sinusoidal voltage, this V is equal to BP sin omega t, no? Because sinusoidal voltage slowly now, alternating voltage slowly, and the current through the resistor due to the voltage source can be calculated from this Kirchhoff's law. Current calculate ለማድረግ Kirchhoff rule ነው የምንጠቀመው. So using the Kirchhoff's law, the summation of voltage that passes through the capacitor is equal to 0, which implies voltage is equal to the capacitor Q, the charge Q over the electric current that flows per unit time is known as charge. So Q over C. C is the capacitor. Okay, C is the capacitor. Q is the charge. Charge flow per unit time per C. So V is equal to BP sin omega t. Here we set Q, the charge Q. Okay, the charge Q is equal to C times V. V the more BP sin omega t. This V is equal to BP sin omega t. We can put it like that. Yeah, r.m.s B ስለሆነ ከዛ ምንድነው የምናገኘው? Here Q is the charge on the capacitor, C is the capacitance, and the V is the potential difference across the capacitor in this formula. So the current through the circuit is obtained by current is equal to the charge flow per unit time, the rate of charge flow. Current is the rate of charge flow is in a second or within a moment. So delta Q over delta T is current. So this delta Q over delta C, Q is equals to CV now. So let's see C times V. C times delta V over delta T ይሆናል ማለት ነው current ይሄን ወደ change in V over change in T with the derivative form በምንቀይርበት ጊዜ C times D over dt D of BP sin omega T because V sin omega T ነው so BP sin omega T ይሄ ወዴት ነው የሚመጣው cos omega T ይመጣል derivative ስናደርገው D over dt BP sin omega T that is BP omega cos omega T omega cos omega T ነው የምናገኘው ይሄ ፓርት ይሰጠን ማለት ነው ስለዚህ C BP omega cos omega T that is the current in this capacitive circuit ስለዚህ አሁን ምን ሆነ የከረንት እና የቮልቴጅን እንትን በምናይበት ጊዜ ከረንት በኮስ ኦሜጋ ቲ ነው ቮልቴጅ ደግሞ በሳይን ኦሜጋ ቲ ነው ስለዚህ ምን ሆነ ኮስ እና ሳይን ግራፍ ነው የሚሆነው ማለት ነው ኮስ እና ሳይን ነው የሚሆነው so cos graph sin graph ከዜሮ ነው የሚጀምረው this is the voltage graph look VP sin omega t ከዜሮ ጀምሮ sin graph እንደዚህ ነው cos graph ደግሞ ይሄን ፖይንት ወደ ኋላ ኤክስቴንድ ብናረግ ከማይነስ pi over 2 ተነስቷል ይሄ ከዚህ አካባቢ የተነሳ ግራፍ ነው ስለዚህ pi over 2 3 pi over 2 እያለ ይቀጥላል so this one is current graph okay current is cos graph cos reaches maximum at 0 okay sin reaches maximum at 90 degree ስለዚህ ይሄ እንትናችን ሊያሳየን ይችላል ማለት ነው so cos and sin so current and voltage are out of phase now in pi over 2 the difference between current and the voltage the phase changes 90 degree now so in capacitive resistance that what we call a reactance ነው የምንለው capacitive resistance ምን ብለን ነው የምንጠራው reactance reactance እንዴት ነው የምናገኘው ለምሳሌ ከዚህኛው ፎርሙላ I is equals to C BP omega ነው cos omega t ነው so ይሄን ፎርሙላ ዳይሬክትሊ ወሰድኩ I is equal to C BP omega cos omega t sorry cos omega t ደግሞ ስንል ወደ እንትን ስናረግ ይሄ cos ለምን cos omega t ማለት ደግሞ sin omega t plus pi over 2 ይሄ ነው ብናባዛ sin omega t plus pi over 2 ብናባዛ ይሄን እናገኛለን ማነው በትሪጎኖሜትሪክ ሪሌሽን ተጠቅመን ያን ሳብስቲቲዩት እናደርግና current is equals to omega cp cvp sin omega t plus pi over 2 so finally what we can get for the maximum condition for the maximum amplitude condition current is equals to omega the angular speed c the capacitor and bp is the peak voltage which is equal to in wc እንትን ብና 1 over wc ብናረጋው ይሄ አሁን ብናባዛ ተመልሶ ይሰጠናል ያን ይሰጠናል አይደል ስለዚህ ሪስፕሮካል አርገናል ማለት ነው so bp over 1 over omega c ይሄ ማለት ደግሞ ምን ማለት ነው bp over 1 over omega c is the reactance when capacitive resistance የምንለው ነው xc ይሆናል ማለት ነው so xc ማለት ነው 1 over omega c ማለት ነው so current is equal to በዛኛው በፒውር resistive circuit ላይ current is equals to voltage over resistance ነው voltage over resistance ነው እዚህ ጋር current is equals to voltage over reactance. Reactance is known as capacitive resistance. Okay, so that capacitive resistance reactance is equal to 1 over omega c. ይሄን እቺን ፎርሙላ ኦሜጋ ሲን ኦቨር አድርገን ያመጣ ነው ምንም ነገር አይደለም ወይም ደግሞ እንደዚህ ቀጥታም መስራት እንችላለን ካፓሲታንስ ካለ ቮልቴጅ ካለ ራዲያል አክሰለሬሽን ኦሜጋ ቬሎሲቲ ኦሜጋ ካለ ቀጥታ እዚህ ፎርሙላም መጠቀም እንችላለን ኦር ይሄን መጠቀም እንችላለን so this is called capacitive reactance or reactance capacitive resistance or reactance so that this is what we want to drive so xc c የሚያሳየው እዚህ ጋር ምንድነው ካፓሲታንስ መሆኑን ለማሳየት ነው xc xl የሚባሉ በኋላ ኢንዳክቲቭ ሪአክታንስ xl ስለሚመጣ xlን ከxc ለመለየት capacitive reactance መሆኑን resistance መሆኑን ወይም ደግሞ reactance መሆኑን በዚህ መለየት ትችላላችሁ ማለት ነው so the capacitive reactance resistance or restricts the passage of current in primarily capacitive circuit in the same way as resistance hinders the passage of current in purely resistive circuit ለምሳሌ resistance ቀደም resistive circuit ላይ resistance here resistance the resistive circuit ላይ current flow restrict እንደሚያደርገው ሁላ እዚህ ጋር ደግሞ capacitive reactance በካፓሲተር ላይ የሚያልፈው እንትን የሚቃወም ማለት ነው that means and the SI unit also ohms no still the SI unit of XC is ohms okay that is ohms now let's take example an alternating supply has a frequency of 50 Hz frequency f is given okay 50 Hz or 50 cycle per second. Hertz ማለትና cycle per second ተመሳሳይ ናቸው. The capacitor is connected in circuit with alternating supply as shown in figure. We have here an alternating supply. The r.m.s says current is passing through this. Okay, so the value of capacitor is 1 microfarad. Look, capacitor C. Unit ምንድነው farad ነው farad or we can use most of the time we use microfarad micro የሚል በመጣ ቁጥር 10 the power of micro ካለ ደግሞ 10 the power of -6 farad ማለት ነው so that is the capacitor unit. What is the reactance of the capacitor? Reactance of the capacitor is the XC ማለት ነው. Reactance of capacitor is XC. What is the peak current? So again at the same time we can find passing through it. peak current በዛው ካልኩሌት ማድረግ እንችላለን ፍሪኩዌንሲ ተሰጥቶናል ካፓሲተር ተሰጥቶናል ቮልቴጅ ተሰጥቶናል ኦኬ የተፈለገው ምንድነው ሪአክቲቭ reactance of capacitor ስንት ነው peak current ስንት ነው የሚለው ሰርኪቱ ይሄ ነው so to calculate xc is equal to 1 over omega c or which is equal to omega ማለት ደግሞ 2 pi f ነው we know omega is equals to 2 pi f 2 pi f ከፍሪኩዌንሲ ጋር ያለው ዝምድናቸው እንደዛ ነው that means ፍሪኩዌንሲ ፈልጉ ብትባሉስ ምንድነው የምታደርጉት ፍሪኩዌንሲ f is equals to omega over 2 pi ኦሜጋ ኦቨር 2 ፓይ ኦሜጋ ተሰጥቷችሁ ፍሪኩዌንሲ ፈልጉ ብትባሉ ኦሜጋ ኦቨር 2 ፓይ ነው። ሌላ ደግሞ ታይም ፔሪድ ፈልጉ ብትባሉ ታይም ፔሪድ ቲ ፈልጉ ብትባሉ t is equals to 1 over frequency ነው። t is equals to 1 over frequency ነው። don't forget. that means ምን ማለት ነው? t is equals to 2 pi over omega ማለት እኮ ነው። 2 pi over omega እነዚህ ነገሮች አስታውሱ። okay so xc እዚህ ጋር መፈለግ እንችላለን። ለምን ፍሪኩዌንሲ ተሰጥቶናል፣ c ተሰጥቶናል ካፓሲተር so 2 pi fc ተጠቅመን ቀጥታ ማግኘት ነው። so the unit is ohm. The reactance, the unit of reactance is ohms. ከዛስ current ፈልጉ ለምለው current is equals to bp over 1 over omega c or bp over xc. ስለዚህ ቀጥታም በማስገባት መስራት እንችላለን። ለምን current is equals to omega times c times bp ነበር አይደለም? ይሄን ነው ወደ ታች እንትን ያደርገው። ኦሜጋ ይፈልጋል። ኦሜጋ ከምንድን ነው የምንፈልገው? ኦሜጋ is equal to 2 pi f በማድረግ ኦሜጋ እንፈልጋለን። ይሄ ማለት 2 pi f times capacitance c times v ይሄን ፎርሙላ በመጠቀም current ማግኘት እንችላለን። so it is very easy. now the next is instantaneous power. What is instantaneous power? Power, as we know, it is rate of doing work. So the instantaneous power supplied to capacitor can be given in terms of current and the voltage. So the current is Ip cos omega t. Now current and voltage are out of phase this time. In the capacitive circuit, they are out of phase. So Ip cos omega t times Bp sin omega t. Now Ip Bp yotana sin omega t cos omega t. Now we have to go for trigonometric relation for sin omega t cos omega t. Nazi ለምሳሌ sin a at cos at ቢመጣ cos at ቢመጣ ይሄ ቀጥታ ምንድነው 1 over 2 sin ይሄ ማለት 1 over 2 times sin 280 ማለት ነው። ስለዚህ ያን ሪሌሽን ትሪጎኖሜትሪክ ሪሌሽን ተጠቅመን ይሄን እንተካለን ማለት ነው በእነዚህ በሁለት ቦታ ላይ። so which gives us 1 over IPBP 1 over 2 IPBP sin 2 omega t. That is the power in the capacitor. So finally the power in capacitor is equal to IPBP over 2 sin 2 omega t. So if the for a complete circuit, okay, for complete cycle omega t is equal to 2 pi, okay, then our value gives us 0. The power is 0 at complete circuit, but in the middle we can find the power at every point. Okay, so this is the voltage circuit, this is the current circuit. Okay, so the current and the voltage are in 90 degree out of phase. So current leads voltage. The current is here, voltage is here. This is the So we can say in the case of capacitor, the current leads the voltage by pi over 2. 90 means pi over 2, is it? በራዲያን በምንገልጽበት ጊዜ pi over 2 or 90 degree. So current leads voltage. Initially in the resistive circuit, current and voltage are in phase so that there is 0 degree. So that is maximum power condition. Now, let's come to inductive circuit and alternating current. So this is the third one, resistive, capacitive, and inductive. So inductive circuit and alternating current. So this is the schematic diagram of inductive circuits. This is L represents inductance. Okay, current I is passing through the inductance, and the sinusoidal voltage is there. Okay, so alternating voltage is there. So what is the condition? Look, this is sinusoidal voltage. The current I is passing through the inductance L. So this is the circuit. An inductor is the coil that stores electrical energy. Look, what is the function of inductor? To store electric energy in magnetic field as a current passing through it. Okay? The main function is to store energy. The inductor is composed of wire that has been wrapped into coil. So these are wires wrapped into coil. Look, these are the wires, inductor circuit. When the current flows through the inductor, the time varying magnetic field produces an induced electromagnetic force, and that obstructs the current flow. Okay, so inductance is the property of an inductor that opposes the change in current. So in inductance, current will flow in one direction. Okay, current is flow in one direction, and the circuit or the inductance circuit opposes the change in the direction of the current. Okay, so Henry is the unit. We use Henry for inductance. Okay, and the inductive resistance is defined as the resistance to the flow of the current flow. Inductive resistance or inductance is inductive resistance is called inductance. We call inductance which is the unit is Henry. The pure inductive circuit has no capacitance and no resistance. Like in the resistance circuit, capacitance and resistance, capacitance and inductance እንዳልነውላ pure inductive circuit ላይ resistance እና capacitance የለም ማለት ነው። only inductance ነው ያለው። እዚህ ጋር አሁን inductor ብቻ ነው። ስለዚህ resistance እና capacitor የለም እዚህ ጋር ማለት ነው። So the current in this type of circuit lags behind the voltage by 90. ቅድም በካፓሲቲቭ circuit ላይ current leads voltage by 90 ብለናል አይደለ? አሁን ደግሞ current lags, current ወደ ኋላ ይቀራል 90 degree. Okay, so now look, this is the current and this is the voltage. So now when voltage here, current is here. So current lags voltage by 90 pi over 2 or 90 degree. The difference is like this. ቅድም ምንድነው ያልነው? ከኋላ በኩል voltage ገና እያለ current እዚህ 0 ላይ ነው ማለት ነው። So now current lags voltage by 90 degree. So this is the representation. XL ነው የምንጠቀመው በኢንዳክቲቭ ሬዚስታንስን XL ነው። Okay, so voltage for inductive resistance BL differentiate ለማድረግ ነው። L BL is equal to BP sin omega t. Okay. Now the induced electromotive force, which is equals to minus L di of t dt. I is the current at which flows through at time t. So induced electromotive force እንደገና ደግሞ this VL is the induced electron, that is BP sin omega t. Okay. So ይሄን ሁለት ኢኩዌሽን እንትን ስንለው ይሄን ለምሳሌ 1 ብዬ ብል 1 ይሄን ደግሞ 2 ብዬ ብል substituting 1 and 2 in terms of induced electromotive force E, we can get this equation BP sin omega t, which is equal to minus L dit dt. So from that relation, what we can get, di is equal to BP over L sin omega t dt. Now, in integrate በማድረግ current from 0 to I, time from 0 to t, integrate በማድረግ current is equal to BP over omega L. Then integrate ስናደርግ omega t እዚህ ጋር አለ. So finally what we can get 1 over omega አለ. BP over L አለ በመጀመሪያ 1 over omega ሲመጣ BP over omega L cos omega t. The maximum condition cos አንድ በሚሆንበት ጊዜ ምንድነው የምናገኘው? I is equals to the maximum condition I is equals to BP over omega L ማለት ነው, which is equals to BP over omega L. L inductance ነው. So omega L is equals to XL ይሆናል ማለት ነው. Yeah, so this is the relation. XL is equal to omega L or omega minus 2 pi F ስለሆነ 2 pi FL is the inductive resistance. Is the opposition provided by pure inductance to the flow of AC current, and also known as inductive resistance. We call XL as inductive resistance. Okay, XL is inductive resistance. XL is equals to omega L. L is inductance, omega is the 2 pi F, so which is equals to 2 pi F L. Yeah, so ይህን ይመስላል. So current is equals to VM over XL. ይህን ፎርሙላ መያዝ ማለት ነው. So this is a just summary of the previous so what are the circuits? This is the circuit representation, or someone can represent it in this form. Okay, so this is L, VL passing through it, and the current lags voltage by pi over 2. Look, voltage 0 ላይ ያለ current minus ላይ ነው ያለው. ስለዚህ it is lagging, current is lagging. Okay, በዛኛው ጊዜ በካፓሲታንስ ጊዜ ምንድነው ቮልቴጅ 0 ላይ ያለ current 90 ላይ ነበር. current እዚህ ጋር ነበር አይደለ? አሁንስ ቮልቴጅ ላይ 0 ቮልቴጅ 0 ነው, current ግን minus pi over 2 ላይ ነው. ይሄ minus pi over 2 ነው. ወደዚህ positive pi over 2, ይሄ minus pi over 2. So it lags. The voltage leads the current by 90 degree. Voltage leads by this 90 degree. From here to here 90 degree ማለት ነው. በዚያን ጊዜ current leads voltage ነው. አሁን ደግሞ voltage leads current ነው. So finally inductive resistance is equal to omega L or 2 pi FL ነው. ይሄን አይተናል. So this is just summary, and the unit also still ohms. It is still ohms. Resistance, all resistance unit is ohms. Okay, let's see some more example. Alternating supply has frequency of this hertz. Okay, an inductor is connected in circuit with alternating supply as shown. So this is the inductor, which is connected to the circuit. This is our inductor. The inductance of the inductor L is equals to 1 micro Henry. This is Henry. Where mu means micro, that is 10 to the power of minus 6. Always in the በምናይበት ጊዜ ማስታወስ ያለብን 10 to the power of minus 6 እንዳለ ማለት ነው። ለምሳሌ 1 ማይክሮ ሄነሪ means 1 times 10 to the power of minus 6 ሄነሪ ማለት ነው። በኤስአይ ዩኒት ስናስቀምጥ sorry. So substituting these values into this equation, we directly obtain the result XL, or the inductance of the inductor, the reactance XL, the reactance of the inductor 3.145, or it is 5 times 10 to the power of minus 4 ohms, or 3.1415 times 10 to the power of minus 4 ohms. ማለት ምንድነው? 3.1415 ያለ የሚቀጥል ቁጥር ነው። So this is all about today. In the fourth lecture, we will see what is the power factor in AC circuit. So that will be the last of chapter 7. So this is enough for today. If you have any question, if you have any query, and if you are having some discomfort, so please share your idea. Just ask the question. I can help you only. So the main intention is to help you guys. So see you in the next class.